All right, so I think this is recording. Let's take a look here at number 10. It's a quadratic inequality. It's being compared against 0. That's what we need. There is no greatest common factor. The leading coefficient is 1, so it's going to be easy to factor. A lot of people don't need to write the x when it's leading, because all you're looking for is numbers that multiply together to get you positive 15, but add to get you negative 8. So that's going to be negative 3 and negative 5. So really, you can see it by inspection most of the time, but if you just are in that habit of making the x, that's fine. The first times the last is 15x squared. And like we said, we've got negative 5x and negative 3x that multiply together to give us the top expression, but add to give us the bottom. Since the leading coefficient's 1, we don't have to make the table. We can just come right in and say x minus 5 times x minus 3 greater than or equal to, or excuse me, strictly greater than 0. That divides my number line, these critical points of 5 and 3, divide my number line into 3 regions. I'm going to leave those hollow because my inequality is a strict inequality. It does not say greater than or equal to 0. It says strictly greater than 0. So I'm going to make a table where my first column, I'm just going to label it test point. Or you could, sometimes I put region up there. I don't know for sure if I'm this table is just to help me with organization, but sometimes I don't know how consistent I am with the column headings. So in region A, I'm going to pick a test point. In region B and in region C, a test point. A number that's in region A that's smaller than 5, I'm just going to pick 0 because that's easy to do arithmetic on. Okay, I'm not very smart. Look, 5 is not less than 3. Oh my gosh. 3 should be to the left of 5. All right, but still, 0 is smaller than 3. A number that's between 3 and 5 is 4. A number that's larger than 5 is 6. So let's come in and replace x with 0. We get negative 5 times a negative 3. That's positive 15, and 15 is greater than 0. That's a true statement. If I plug in 4, 4 minus 5 is a negative 1. 4 minus 3 is a positive 1. That product is negative 1. And negative 1 is not greater than 0. That's a false statement. So I'm not going to shade in anything from that region. If I replace x with 6, 6 minus 5 is 1. 6 minus 3 is 3. 1 times 3 is 3, and 3 is greater than 0. That's a true statement. So I'm not going to shade in the middle part, but I am shading in the tails, the part that's away from the middle. You pick any number that's in the shaded region and plug it in the original inequality, and you'll get a true statement. Pick something that's not in the shaded region and plug it in, and it will be a false statement. We want to describe this picture using inequalities. Now, sometimes I'll say using interval notation, which will be true 90% of the time for the whole year. As soon as we learn interval notation, we use it consistently throughout the year, and that'll be in the next skill packet. But right now, let's just stick with inequalities. X is less than 3. Since we have a jump here, we need the word or. I started to write the mathematical symbol for or is a union. But again, we learned that with the interval notation. So x is less than 3 or x is greater than 5. There's our final answer for number 10. Hope that helps, and I will talk to you later. Bye.